Welcome everyone. Thanks for joining us for another Hero update webinar. This one on our recently released version 3.1 update. Nice to see everybody here. So this is an update on the latest release. If it was meant to be an hour, I think it's going to go a little bit over. So if we do go over and you need to run, don't worry, it's all being recorded and we'll share a link to this later on. So let me begin. So today with our recently released Hero version 3.1, it's another big update for the platform, comprising a range of new features. Importantly, it is our first NatHERS 2022 accredited release. So this is for the thermal fabric. So for the NCC 2022, obviously we're moving to 7 stars for many states, as well as a whole house component. Version 3.1 is our thermal fabric accredited release for that NatHERS 2022 element, with whole house coming shortly down the line. So I won't talk too much about whole house today. We'll hopefully be talking to you guys soon about that over the next month or so. And yeah, obviously really aiming for that 1st of October date for that whole house to be out, given that Queensland and ACT are looking to take it up by the 1st of October. But just to kind of close out the whole house thing, as of 3.1, you can do an NCC 2022 assessment using Hero. You'll do a NatHERS thermal fabric certificate and then comply with the whole house elements through, say, DTS whole house calculator. If you haven't seen it, because some people still aren't aware of the DTS whole house calculator. I must have accidentally closed it very quickly, sorry. The ABCB have a whole house DTS calculator that's available. So in combination with a NatHERS thermal fabric, you can use this whole house DTS calculator to meet whole house compliance. It's obviously got its limitations, and the NatHERS whole house will, contain a lot more detail and analysis for you, but there is a pathway now for those getting a bit freaked out. You can achieve NCC 2022 compliance at the moment. So today I'll be running through these main topics here. We've got these NatHERS 2022 aspects that I'll touch on. I'll delve into the thermal bridging and structural options of Hero. We have a new optimization feature, our first implementation of that, which is a really powerful batch simulation feature. It allows you to queue up lots of different variations of your projects in different powerful ways. We have a really cool thermal comfort feature that we've added with 3.1 that is about analyzing your passive performance of your homes. We have a new hourly results viewer, so you can analyze and understand the model a bit better. A range of minor updates, and then time permitting, we'll hopefully take a few questions at the end. So NatHERS 2022, as I've mentioned, 3.1 is NatHERS accredited. It's a conditional accreditation, waiting for our whole house accreditation later on, but it is accredited to produce NatHERS 2022 certificates, and allow you to do a full thermal fabric simulation using the new 2022 NatHERS methodology. So if I just jump into Hero, I'll be jumping in and out and showing you around Hero today. Let's just load up a simple project. In Hero, it's as simple as in the what we call the project data grid tab here. For your project to run in a 2022 NatHERS profile, you simply can switch this NatHERS profile combo box here from 2019 to 2022, and then you're away. So there's no separate versions of Hero for 2019, 2022. For all of those who are not in states like South Australia, WA, Tassie, not moving into 2022, you can still run using this latest Hero for your 2019 assessments. You'll still be able to produce 2019 NatHERS certificates on the web portal. And for those states like New South Wales, Queensland, Victoria, etc., who are ACT, are moving to the NCC 2022 at some point over the next 6 to 12 months. You just flick this to 2022, run your simulation again. And what it does in that is it just uses the new 2022 methodology. And the main changes for that in 2022, as I'm sure most of you are aware, we have new weather files. So all of the 69 NatHERS climate zones have been updated. They're a decade or two shifted closer to the present than the 2019 weather files. And so you will see some simulation changes. You know, I know Melbourne seems to be like a clearer weather file. So you'll see kind of solar passive designs in Melbourne usually perform a bit better. You will see results shifting between 2019 and 2022, that's for sure. And it's usually this weather file, these weather file changes that have been updated for all the climate zones. So they're more recent data, kind of a little bit of a warming trend, those kind of things. The other aspect of 2022 that's changed is obviously with that weather file changes, there are new star rating bands. So the star rating bands are what, you know, how much energy is a 6-star home, a 6.5, a 7-star home, the different bands of what the star ratings are and the required energy. They've all updated in 2022. We have a few minor thermostat changes in 2022. And the other large change in 2022 is new heating and cooling load limits. So the ABCB published these load limits. We have new heating and cooling load limits for 2022 for a variety, for the, you know, class 1, class 2 apartments, different heating and cooling load limits, concrete slab on ground versus suspended floors, different heating and cooling load limits there. So we've integrated that into 3.1. Likewise, New South Wales projects have updated heating and cooling load limits from the upcoming BASIX updated platform that's hoping to be introduced the 1st of October as well. So we've integrated those heating and cooling load limits for BASIX as well. They're a bit more complex. There's class 2 under 5 stories, above 5 stories. Some of northern New South Wales isn't getting some of these new limits. But we've integrated it, so in many respects you hopefully don't have to worry too much, and we'll be showing you those required limits in your projects. So for NatHERS 2022, just to round out this element, as I said, it's as simple as just flicking the switch, run your results, and you're ready to go in compliance for the 2022. You can then go to the web portal, sorry, let me just bring this up shortly, and produce different types of PDF certificates. And so there have been a range of certificate changes with 2022 as well. This is the old certificate, and we have a new thermal fabric only certificate. Let me bring them up next to each other. So on the left, we have the original 2019 NatHERS certificate that you'll still be able to, if you upload your projects to the Hero web portal using this 2019 profile, run the simulation again and save it. When you upload it to the portal, you'll have this certificate on the left, the original NatHERS 2019 certificate. But there's a range of new certificate design types for 2022 coming in. As you can see on the right, this is the 2022 format. It has the thermal performance, and it also has space for the whole of house rating. But you don't need to populate the whole of house for every certificate. And so this certificate is what we call a thermal fabric only certificate. You'll see here, it has no whole of house performance rating for this certificate. This page is mostly going to be populated again for whole of house. You'll see pie charts of different whole of house elements here. So again, in this thermal fabric certificate, all of the whole of house elements are ignored. There's some new checklists in the 2022 certificate types that have got some kind of almost as-built style assessment checklists that are quite handy and worth exploring. Otherwise, it's relatively similar to the existing certificate format. There's a new section at the back on where thermal bridging gets added. And then for the whole of house aspects, they get added at the certificate too, but obviously not for this thermal fabric certificate. So this certificate type, as I mentioned at the start of the presentation, can be used in combination with another, say, whole of house DTS calculator, if you were wanting to do NCC 2022 projects today, or for projects, say, in New South Wales. New South Wales not having, not integrating the NatHERS whole of home. They have their own kind of whole of home metrics, etc. So for New South Wales basics projects, you won't be producing a whole of house rating. You'll be using these thermal fabric certificate types and submitting that into basics. Okay, so the biggest change from a modeling perspective with NatHERS 2022, apart from the whole of house coming down the line, from the thermal fabric side, is the introduction of thermal bridging. And so this is limited in NatHERS just steel framing, steel frame homes, walls, floors and ceilings are required now to be modeled for their impact on thermal bridging in NatHERS tools. It's a bit of a halfway kind of measure, this steel frame only kind of thermal bridging assessment. Timber frames are left out of this process. And there's a kind of referencing in the calculations that references timber frames such that the performance of a steel frame is only the reduction against an equivalent timber frame home. So it's a little bit confusing. I'll try and step into this in a bit more detail as I take you through it. So in 3.1, we've introduced thermal bridging into Hero via a concept of structural options. And so like every assembly in Hero, like a wall assembly or a floor or a ceiling assembly, where you can have different types of insulation options, like in a wall, you may have different types of insulation options that are available for a various wall type. This is like a brick veneer with a non-reflective cavity. Similar to a brick veneer having various insulation types that you can fit to it. Likewise, we've added this idea of structural options that are various types of structural framing that can be applied to an assembly that represent the different ways that that assembly might be built. So you might have different types of steel framing, even timber framing we've added in, different spacings, different thermal break, different material types, and these kind of things. And so similar to the insulation options in Hero, you can apply these to your projects here in this new structure column in the wall data grid tab, and likewise in the floor and ceiling data grid tabs. And so in your projects, if for a default assembly, an assembly that's provided for you by Hero, we come and we have these pre-populated structural options available for you to select. So if we just started a quick project from scratch, just to kind of simplify things. So if we have a simple box here and we add some insulation to this brick veneer reflective cavity wall, we can simply add steel framing if required to this project based on the structural material of the plan. There is a NatHERS default where that's shown here as the default option. If you don't have enough information on the plans to know what type of steel framing this job has, NatHERS in the new tech notes do provide the default of what you should be modeling. It's kind of like it's not a worst case, but it is the one that you would select if you don't have sufficient information. So you can select this here in the structure and run your model. And what it does, I'll flick to the library view where we've integrated this in a bit more detail. So in the wall construction library, we've had a range of changes in 3.1. to support the introduction of these structural options. You can now select what the visualization of the assembly is in this installation row here, and see what the impact of various structural materials are too. So let's put in that default here in the structure. And you'll see here in this assembly of brick, air gap, insulation, what thermal bridging is basically modeling is we have a continuous layer of insulation previously modeled in NatHERS. It doesn't assume any disruption of that insulation layer. It's an R2 insulation bat. And when we put in a structure material, like we've done here, we see that it bridges that assembly such that the insulation, which was R2, is now bridged down to 1.6. So we can see the impacts of that steel frame in obviously reducing the effectiveness of that insulation. And you can evaluate and see the impacts of these different materials here. You can see when I put in a structural material that has a R.2 thermal break, you can see that instead of a drop to R1.6 in this bridged column here, it's just dropping that R2 bat to 1.84. So structural materials are basically just secondary materials that disrupt the main material layer of an assembly. You can have multiple structural materials where you can, if you had multiple insulation materials, I added in another insulation material, such that we've got two bats here. They might not be placed there, but I can now just drag in another structural material from the bottom here, and the structural framing in each of those layers might be different. You might have battens or smaller framing types, different spacing or whatever, and you can likewise model those individually in the drop down here, selecting different types of material types, structural materials in your assemblies. So it's just like the insulation options in Hero, where and you can see them in the left here under brick veneer. It has its pre-populated insulation options. These are the variety of insulation types that can apply to this project. We've got R1.5 bats, R2 bats, R2.5, and we can see a range of also these pre-populated structural options that have been created for the project too, that are ready to be used. So it's the same as insulation options. You go to the library and you can create custom structural options for your projects. And then you go back to the data grid and you apply those structural options to your projects, like we've done here, where we've applied that structure to these walls. Likewise, on the floors, we have the same column, a structural column. It doesn't apply for concrete slab or waffle, but suspended floors, which may be insulated, a steel frame floor needs to be modeled in Hero. And again, it's just the same as for the wall data grid tab. You can select the type of framing material. There's a few different types for floors than for walls. And you can add these in and model their impacts on your project here. Likewise, on ceilings, similar, we just put in some ceiling insulation into this project. Let's put in an R3.5 bat on the ceiling, and let's put in a reflective blanket at the roof level, 1.3 reflective blanket. Ceilings, the only difference is it has two structural columns, similar to how we have ceiling insulation and roof insulation. We have ceiling structure and roof structure. So the ceiling structure disrupts the ceiling insulation and the roof structure disrupts any roof insulation. Obviously, it doesn't affect anything like sarking. It only affects bulk insulation like blankets, where it breaks that up. Similarly, the summary view has the same structure columns added into the various tables of the summary view. The summary view being where we create bulk changes in Hero, where we can select one row of the summary view where all of these walls match these attributes, and we can bulk change all of the walls with kind of one click and change the structure like we did in the data grid example. And you'll see in the floors, it's the same here. So we have these structural options also added into the summary view. And the assembly view of the summary grid, which the assembly tab of the summary view is a printout of all the existing assemblies that are in use in your project, all of the wall assemblies that are in use. And you can see here in this project, the only wall type we've got is a brick veneer R2, and it's bridged by this type of steel framing. So that's basically how you can apply and use the new structure options in Hero. The only additional aspect to this thermal framing conversation is a range of settings. And I've forgotten to tell everybody, but they're in our support page. There's some new support user manual pages on the Hero support desk for that NatHERS 2022 conversation that I started the webinar with, and a new page on structural options and thermal bridging that'll take you through this in much more detail than I can in an hour webinar, or that if you need future reference, similar to what I'm discussing today, you can go to that page. The last thing to add for thermal bridging is the way that thermal bridging gets applied in Hero is based on a thermal bridge setting. So we have the NatHERS profile here, 2019, 2022. 2019 obviously comes with no requirement to model thermal bridging. And so we have this setting here called thermal bridging. And there are three settings: none, which is fairly self-explanatory, NatHERS, and full. And so I'll just go through those quickly too. So when you're in NatHERS 2022 mode, you should be modeling, if you have them, you need to be modeling steel frames. The NatHERS technical notes, though, has a range of conditions of where steel framing needs to be modeled. And so in this setting that's called NatHERS, it's basically Hero doing all of the tech notes requirements for you. So if I can bring up that user manual page again, in the tech notes, there is a bunch of areas where thermal bridging must be applied and where you can ignore it. So it's saying here, you must apply it to external walls, but you can ignore it for unconditioned garages. And you can ignore it for internal walls between two condition zones. And so rather than us forcing our users to understand and remember those specific conditions, what we recommend people to do is just model your steel framing as per the plans, just put it all in. If everything's steel framed, then almost every wall, floor and ceiling is going to have one of these structure options. And when you're in this NatHERS setting of thermal bridging, we'll only model the impacts of thermal bridging for those walls, floors, or ceilings that meet this NatHERS tech note requirement. And so even if you have structural options applied to an unconditioned garage, we won't model their impacts in the NatHERS setting. Even if you have structural options added to internal walls between two condition zones, we won't model that in NatHERS setting. Just to kind of not disadvantage people, I suppose, who are adding structure options throughout the house. We do want to use this structure framing for more purposes than just thermal bridging in NatHERS. It'll feed into other things like embodied emissions calculations in the future. And so that's why there are these kind of settings that we've added into the tool. So NatHERS as a setting also has this, so it's about the location. We'll automatically model thermal bridging where it applies from the tech notes. But we also in this NatHERS mode do a dereferencing against an equivalent timber frame home. So in the NatHERS thermal bridging methodology, which you can find out more about on the NatHERS webpage, they've got a whole paper on the NatHERS thermal bridging methodology. But because timber frames aren't modeled, what they've had to do is reference the equivalent or the reduction of your steel frame compared to an equivalent timber frame. And so if a timber frame was going to reduce your R2.5 BAT to 2.3, and a steel frame was going to reduce that 2.5 bat to 2, then it's only the difference between the steel and the timber that gets modeled as an equivalence on your steel frame. So pretty specific to Australia, ABCB, NCC, kind of NatHERS world, but anyway, that's what we're with. So the other settings in this thermal bridging section of the project data grid tab, you have none. It's a nice way to just kind of quickly turn off all structural options in your model and not model their impacts. So in 2019, you can leave it on none. Or if you don't have steel frames, you can leave it on none. And then we have this setting called full. So as I was showing in the data grid and in the library, there are timber frame options. Obviously, timber frames do disrupt insulation. They do have impact on the insulation's continuity. So you can select in your project's timber frames if you wish. And in the NatHERS mode, they're going to be ignored for their impacts because they're not part of this NatHERS kind of thermal bridging requirement. But if you're wanting to model more accurately your designs and use this and use it for design analysis and improvement and comparing different framing types, etc., we have added this setting full. And so that just basically means that whatever you've modeled gets simulated. So there's none of this tech notes of an unconditioned garage doesn't have its insulation bridged, even though in reality, obviously, if you've got insulation in a garage, it will get bridged by the frame. So we've added this setting called full, just kind of does it more closer to kind of how you might expect or how reality might occur. So it ignores all the NatHERS kind of locations where you need to model thermal bridging. It just does what you have in your model. It doesn't do this steel frame dereferencing against timber. It models steel as it is. It models timber as it is. And so that's what this thermal bridge full setting is. And so you can see the impacts of that in the library relatively easy. There's a setting at the top of the wall library where you can change that setting. And you'll see in this example, when I change from NatHERS, if you just watch the total R value here or the individual row, this R2.5 bat is getting bridged to 1.98 when it's in full. And when it's in NatHERS, it's actually only 2.21 bridged because it is doing this timber dereferencing. So the full is obviously just an optional beyond compliance setting that you might want to use. Optimization is the next thing. Actually, I wanted to start with the thermal comfort feature, sorry. So another thing we've added into Hero 3.1 is a new feature that we call the thermal comfort aspect of Hero. And basically, this thermal comfort feature is about trying to support ways of analyzing the passive performance of a house. So when we run NatHERS condition models in NatHERS assessments, they're always conditioned, right? Like a bedroom or a kitchen is always going to have heating and cooling applied when it drops below the set points that are set by NatHERS profiles. So while that is a good proxy to understand how well that house might passively perform, it isn't the actual prediction of how well the house passively performs. And my experience has been that it is a really great metric. It is a really great communication point to be able to discuss passive performance to your clients, to designers, to architects, and use and to occupants. And because many occupants they're wondering how well my house performs, how hot it's going to get, how cold it's going to get. Do I need to run my air conditioner all the time, or can it just sit there without heating and cooling a lot of the year? And so the thermal comfort feature in Hero, we turn it on here in the thermal comfort section of Hero. We turn it on, enable, and it allows you to run a parallel simulation. So an additional Chenath simulation that is your thermal comfort model. So you've got your NatHERS thermal fabric model, and you turn on this thermal comfort thing, and you have the ability to select a profile that's going to be your thermal comfort model. So most of the time, these thermal comfort models the feature is meant to be used for passive performance. And so the profile that we use for these models is usually what we call a free running profile. Free running meaning it has no heating or cooling added to it. And so you can select various profiles that you might want to use for your thermal comfort model, but these two free running profiles are the most appropriate. The second one here is a free running profile, so no heating or cooling, and it has no natural ventilation. So that may be something you want to look at as well. How well does this house perform when the windows are all shut up and no one's running around opening windows and ventilating? And let's see how the performance goes. So you turn on the thermal comfort feature here. Now, whenever you hit run, it's going to run two simulations. It runs them in parallel. It uses multiple cores of your computer. And when we run this project, the calculate hourly results setting needs to be on. This is a new setting. Just means at the end of the Chena simulation, we're going to keep all of the hourly results of your zones so that we can do comfort analysis. And so I'll just run this square box very quickly. It's going to give us pretty junky results. It's running two simulations there. It's got our star rating run, 2.6 stars, 1 megajoule heating, 135 cooling. But you'll see this thermostat little icon down in the bottom right here saying 46.6%. And this is this new thermal comfort rating that we're using, that we've implemented in 3.1. And it's based on that thermal comfort model's results. And where you kind of visualize these thresholds and where you customize this is in the results view. It's related to this new hourly results viewer that we've implemented and that I'll be discussing next. But it's this right-hand side section here that's called thermal comfort. And so here, it's similar to those settings. We're just replicating those settings. But the thermal comfort rating is based on these comfort thresholds of hot and cold that we've added. And so it's a relatively simple comfort metric where we can set for our project a hot threshold. You can set whatever you really want as the threshold for that, and a cold threshold, and you can set whatever you want for that. And what it will do is use that comfort model, that free running, passive, no heating and cooling, and work out the number of hours that the zones of that house are above this 30-degree hot threshold, below this 15-degree cold threshold, or whatever cold threshold. Let's put something in so it's not 0. And then the rating that we're seeing in the status bar of the main screen is this comfort rating here. See, 72.2% is an estimation of the number of hours in the year that that project's going to be comfortable based on these thresholds. And so we think this is a really cool way of adding greater analysis and depth to your design analysis and your consulting. And we'll be adding to this in future a few new metrics there of temperatures and these kind of things. But it does allow you to start discussing how well a home performs passively with your clients. And so this project here, based on this kind of range of thresholds, and depending on where your project is and the client, you might change these thresholds. It's suggesting here that this project is comfortable 72.2% of the year. And so that's basically a thermal comfort feature in a nutshell. As I said, it is about analyzing the passive results. I'll show you how that kind of looks a bit more when we step into this hourly results viewer, and they go well hand in hand. Just to note, the last thing to close out that thermal comfort section, in the project data grid tab, we have the setting here, calculate hourly results as well as save hourly results. And so that save hourly results is another option. You can check that. And when you save your hero file, it'll also save all of these hourly results such that you can use, they'll be loaded in straight away and you don't need to re-simulate. So in 3.1, we've also introduced a hourly results viewer that's really handy to, again, analyze, improve your designs, target poor performing rooms and projects. And so when you've run a project with this calculate hourly results setting on, whether it's a thermal comfort rating or just a normal thermal rating, you can now go to the results section of Hero. You've got your standard results section where you can see the condition, thermal fabric results, star ratings of zones, etc., heating and cooling loads. And you can go to the new viewer, which is our hourly results viewer that we've added into Hero. And so to take you through this new view, we have a toolbar down the left that has a few settings that are kind of replicating what we saw in the data grid of whether we're calculating these. We can show various results in the graphs in front of us here. And so in this project, we have two sets of results. We have the thermal fabric star rating results. That's a condition profile. And we have this comfort model that I ran before that is a free running profile. And so you can actually change and visualize the different results of that model. Let me flick to thermal rating. There are a number of charts that we've added in here. So the first one is, the top one is temperature chart. Temperature on the left, date along the x-axis. And the bottom one is the energy. So this is the heating and cooling loads of your project. And just show it a bit closer. You'll see here is a day, January 14th, all the hours of the simulation. And you can see in the bottom section, this is the energy. These are the thermal loads of each of the zones throughout the day. And as I said, you can flick between these two different profiles. We can choose the comfort profile here. You can see there's no energy in the comfort profile because it's a free running mode. And you'll see the temperatures are quite different to the thermal rating zone, because when we're in this thermal rating zone, we can see lots of flat lines, and that's basically when that zone is getting conditioned. You can see it's getting cooled down. It's a hot day. A lot of these zones are getting conditioned, and that's why their temperatures are flat. You can include unconditioned zones on the charts here, add them into the graph using this option on the left, and then in this dwelling and zone selection area, you can select or filter out objects, zones that you don't really want to see. So you might be just focusing on a specific area that's of problem. You can use these clear or select all to quickly focus in. Like we might just be looking at, say, the kitchen versus outdoor temperature. So that's along the left. On the top toolbar of the hourly results viewer, you have some date ranges that you can choose. And so, yeah, that's relatively self-explanatory. Start date, end date of our chart here from 1st of January to the 31st of January. We can you can use the button next to it here to zoom in on specific areas. You might say, oh, that's looking like a really hot week. What's going on there? And you can zoom in on those areas. You can use this fit width shortcut buttons to quickly change the view to see results at different widths. This is a day, 24 hours of results. This is a week. This is a month. And you can even see the whole year. If I go back to a week, there are then the navigation buttons along the top here. So you can use that to skip along and quickly walk through weeks. We're in the week kind of width at the moment. So you can go forward through the year using this, or you can drag this here. This is a similar kind of shortcut to see. You can change the width quite easily using this drag here, or shift that along in the project. Or you can do bigger skips, which skips, I think, a month or every few months, or go right to the end or right to the start. You can also do that in just, you can double click the right side of the chart here or the left to go forward and back. You can even use your keyboard right and left to just navigate quickly. You do want to do this because a lot of the time when you're using these results, the main element of benefit that you're wanting to get out of this is to try to get an understanding of how this project is actually simulating or functioning. And you do that by, once you're using this feature for a while, you'll start to recognize patterns. You'll start to be able to see patterns of performance and understand better this Chenath simulation and what it's telling you about that specific project. So we can see here, if we focus in on that day, we can see here we've got one zone that's always quite a bit cooler, and then other zones that are, you know, relatively hotter. And so we can focus in on this one. It's just a walk-in robe, so that's obviously why it's quite cool. But we can start to see trends of our performance of buildings. This project's showing, you know, that most of the time in summer, it doesn't warm up until much, you know, after lunch, certainly, and into the afternoon. And that is based on this orientation of this job, the home warming up and these kind of things. But it is worth, you know, walking through this, these date ranges and starting to try to pick out anomalies, or why is that happening? Where are my problem zones? What are these peaks that are coming in here? And then you can start to really enhance your design methodologies and say, all right, I've got a big afternoon peak in my bedrooms that are, you know, west facing perhaps. And then you can start to use, you know, apply some changes into the model, run it again, see how the performance is shifting in your project. The last element of the top right is some shortcuts to go to a range of kind of interesting days or peak events. So you can go to the hottest day and see how the house is going. In this project, we're seeing that the house is getting up to really high temperatures by the end of the day. This is a 40-degree day. It's getting up to 40 by, you know, 10 o'clock. And we see that while maybe before lunchtime, the house is, you know, under 30, it may still be kind of habitable. By the afternoon, you know, this house is pretty uncomfortable. It's above 30 in every single habitable space. So we can start to use this analysis. We can obviously export, as per most of Hero's views, you can export these out to image or to clipboard, CSVs to take it for further post-processing. Likewise, in the thermal comfort, I didn't mention that there's ways of exporting all of your hourly free running results from here as well. You also have in the file menu a way to export about all of your results for the different profiles in the menu here as well. So you can go to the hottest peak day or even the coldest winter day. Here it's getting down below 0, and see how much, you know, what the condition of my house is by the end of a really cold night. You know, some of these zones here are still kind of relatively comfortable, well, not relatively comfortable, but some of these zones are, you know, getting down to 10 degrees here at the end of the night. We can start to use these kind of analysis to improve our designs and give better feedback to the designers. The last button here is the group by, where you can accumulate all, average out all of the zone results by selecting dwelling or project. And that's just going to give you the average temperature of the whole house. So rather than looking at all of the individual zones, you might want to use dwelling or project. For a multi-dwelling project, the dwelling will have the individual dwelling averages, and the project would be the project average. For a single dwelling project, this is just the average of all the zones in the one dwelling. And so this might be a bit more useful for some analysis where you're just trying to get a general feel of how, you know, what's the overall temperature on average in the house throughout the year or during certain events. So there's a way to group that there. So just to close off this feature, the other aspect you can do is, you've probably seen me hovering certain elements of the view. You can select them here and try and drill down and just get a bit more visual focus on a specific one by selecting it here. Hit escape to clear that, or you can even hover these things and just kind of pick out which one is these problem childs or whatever. Yeah, so I think that's generally, and to feed back into this, yeah, as I said, the thermal comfort feature really goes hand in hand with this hourly results viewer. You can see here the thresholds that we put in are kind of visually shown on the chart here. So if I change our thermal thresholds, you'll see the hot threshold and the cold threshold can change there. So it's a great way of really seeing passive performance impacts of a home. We could go into much greater depth on this, and you can start to use this for like, oh, here's a really warm east-facing morning, put some shading in, see how that, performance looks. Have you mitigated that, peak summer condition or things like this? I'll now step into the optimization feature, which is another new exciting feature added into Hero 3.1. So with 3.1, we've added our first implementation of optimization, or the O of Hero, Home Energy Rating and Optimization. And so the optimization feature, which you can access at the main toolbar here, the Optimize button, is a way of setting up really nice big batch simulations. So a range of variants and different combinations on your project. So I'll take you through it and try and explain some of these examples. So you load up the view. This is like the setup where you're going to set up your optimization runs, and then it's as easy as just clicking add run, and we get a instruction row added in here. Each instruction row has a type and a type of change. And so in the type, we have a range of the standard kind of categories of model objects in Hero: project, zones, walls, floors, etc. And then in each of these categories, there's a range of things that you can change on that. So for the project level, we can change the climate zone or the orientation, or whether it's mirrored, or its overall air tightness, or even its NatHERS profile. So let's do climate zone. That's a nice thing that you might want to see the impact of your, builders having designs that are used across Australia. Select climate zone. You'll see here we have add value or clear all values, and then we have some presets. These are just kind of shortcuts that you can use to populate different values. So I can just use this add value thing here and simply add a bunch of different climate zones that I want to run for my project, like that. Or I can clear those, and then, or I might just use the presets little helpers here. So, all right, let's run all of the Victorian climate zones, and you can just hit load, and then you'll get all of those NatHERS climate zones that are used in Victoria. So there's a range of, as I said, a range of actions that you can change. You can add multiple instructions, which is really powerful. You could set this up to say, all right, I want to run all of the different variations of climate zones, but I also want to see how my project handles different orientations. So again, a range of different helper orientations. There we could load up 8 orientations, and then you can click this little calculate button. And what we see here is in the climate zone, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 climate zones we're evaluating there, and 1, 2, 3, 8 orientations. So overall, we're about to run 17 simulations. You can choose the number of parallel CPUs that you'll use to simulate that. And then we can kick off an optimization just by clicking the begin optimization button. I won't do that now because it'll run 17 simulations and we'll wait a few minutes. But it'll run each of these variations separately. So using the base file as the input, it'll bring it in, it'll change the climate zone to 21, run a simulation. Then it'll start up a new simulation, bring in that project, climate zone 2022, run that simulation. And likewise, step through all of these and run individual scenarios on these. Then it'll go to the next one and just run individual scenarios on these as well. And so that's what we call a parametric setup of an optimization. The other thing that you can do in Hero, which is really powerful, is there's a second way of setting up these optimization things to be what we call full factorial. And so when you do a full factorial setting, you will run every combination of this climate zone against every other combination of this second variable, which in this case is orientation. And so we can see here, it's updated the total number of simulations. We went from, I think it was 17. We're now about to run 72 simulations. Why is that? So it's 9 climate zones times 8 orientations. 9 times 8, 72. It's every combination of these variables with each other. And so that first scenario will be climate zone 21 with an orientation of 0. And then the second simulation will be climate zone 21 with an orientation of 45. Climate zone 21 with an orientation of 90. All through them, and then into 22 and running all of those. And so you really can do this full factorial as a really powerful way of exploring the design space. Obviously it takes a while, a lot longer to simulate. We'll be providing some tools in the future to hopefully minimize that. But for research projects specifically, and template designs, volume builder template designs that might be, located in various climate zones across various orientations, and maybe even in various left-hand, right-hand, flipping of each other, right? This design might be getting used by a builder in these 9 climate zones. It might have 8 different orientations that, depending on the project, might be applied. And it might be a left-hand version or a right-hand, depending on which way, the driveway is facing or whatever. And so adding in that third attribute, we've now got 9 times 8 times 3, which is 216 simulations. For this project, running in 8 at a time, 216 divided by 8, that's about 30 kind of groups of simulations. So it's about half an hour on this project to evaluate all of those 200 simulations, but you get some fantastic data out of that you can give to your clients. When you run this simulation, as I said, I won't do it here. For this version 3.1 release, it just spits out a results file in a new directory that we add to your computer called the Hero results folder. So you can click this button here at the end of this, the optimization, and in your Hero install folder, there's a Hero software folder where everybody, when you install Hero, it's where your kind of construction library is, where your templates are and everything like that. You'll also have in the simulation folder a results folder, and this is where these optimization results get saved for posterity. You can save these, or they will be saved. You can look them up in the future. And so in terms of the actual results, so here was a optimization that was run, and this is the kind of results file that you get at the moment. And this optimization was just a straight climate zone optimization of a variety of climate zones. And so we ran 20 simulations on this one, and then you'll get the star rating, heating, cooling, and total values there, and you can see the impacts there: 6 stars, 7.9, etc. In this example here, we had this is a full factorial example. Oh no, it's not. It's an example where we have orientation and climate zone. So here we ran 3 orientations, followed by 4 climate zones, so just 7. And you can see those 7 results added in there and the star rating impacts there. The last example is when we do a full factorial optimization. So here, just a simple example of 3 orientations for climate zones in full factorial. So 3 times 4, we're doing 12 simulations of all the different combinations. And you'll see here, so this is the orientation column, and this is the climate zone column. So as I was explaining before, it's run, 4 simulations using 0 orientation across the different climate zones, and then 4 using 180 orientation across the 4 climate zones, and then 90 orientation across the 4 there. So yeah, at the moment, you'll get these results in a CSV. The other thing to note is we've also added in the just general simulations, also have a simulation result here in the results folder. You can see op results, that's an optimization result, but there's also just CSVs that will get produced on every normal run in Hero. So you can just see, this is like a history of all your simulations that we'll be incorporating better into the app. But at the moment, you do now have like a simulation history. So every run you do will now be stored into this results folder and can be a good way of saving out all the different variations that you run just by standard simulations that you do here. John's asking about some optimization categories. So I probably didn't take everybody through enough categories here in optimization. If I clear these, I only showed you the project ones really. But certainly, the main aspect of the optimize feature is you might use it to do sensitivity analysis across various attributes of, say, walls, floors, ceilings, and windows. Actually, one of the articles on the optimization page of our support page kind of shows a few new scenarios that you might want to do. So you might want to set up running an optimization based on changes to the window specification, varying different window specs and seeing what the sensitivity analysis of that variable is on your project. You might want to set up running, again, another sensitivity analysis on wall external color, ceiling external color, or ceiling insulation, or wall insulation, or floor insulation. All of these kind of attributes. This is sensitivity analysis. If people aren't aware of the term, it's trying to work out, you're running 5 different variations of color, seeing whether color is a very dominant aspect in this model, whether wall color is having any real impact from light to dark on your model, and being able to then give your clients, or if you're a designer, use it for yourself, using all of this more greater data to enhance and optimize your project. And so in the floor, we might say, let's run R1 1.5 to 2.5. Let's run floor insulation 0, 0.5, 1, 1.5. Let's run ceiling insulation 3, 4, 5, 6. Oops. Let's run some specifications of windows. The helper here are your window lists. You might have set up some nice window lists here. Let's run some variations on window specification types for your project. Again, this study would be really nice to visualize in this full factorial mode, where you're doing every 4 insulation types against 4 flooring types against 4 ceiling types against 3 window specification types. You can obviously create lots and lots of simulations very quickly when you're in this full factorial mode, or if you're running behind time, you can just use this parametric. We've gone from 200 to 15, and we're just going to run those 4 walls. We'll see what the impact is there, whether there's 0.1 or 0.2 star benefits on each of these, and then you might be able to kind of choose your path forward based on those results. But when you're in this full factorial mode, it's a really great way to just kind of explore the solution set. Last thing to discuss for the 3.1 update, there's a few minor updates that I'll just touch on quickly. I've kind of touched on most of them inadvertently, talking about this new results folder that is taking just normal simulation results. There's been, as you can probably see visually across the app, there's been a design update in terms of the design styling of the app. The other main view that's had a few changes is the wall library, not only to incorporate new structural options and bridging settings and things like this, but we also have a way of, in Hero, for those who aren't using Hero a lot, you have default assemblies. Let me just show you. You can group the assembly library by a new library type. And so in Hero, we have standard assemblies. These are the ones that get packaged with Hero. These are the ones that we built for you, standard templated types of constructions. And then we also have custom library. This is what you've traditionally used in your Hero projects to create your own custom types of different walls. But we've also added a new library type that's the project library type. So previous behavior of Hero would be if you had a custom wall in one of your projects and you saved it into the file and then gave that file to one of your colleagues, they'd open up that Hero file and all of those assemblies would come into their custom library. What you can do in 3.1 is you use this project library. And so any custom walls that you've created for your job can be moved into this project library, and they're only going to get saved into this project library here. And if I create a new project, they'll all be gone. They're only going to be assemblies that are in use in a specific file. So a new project, we see there's no more project library assemblies that got cleared. They were only in that file. So this is pretty handy. What you do is your custom walls that you might create are ones that you might use for lots of jobs. But if you are doing, say, a project where you are modeling every wall type just for that job, what you do, you create your assembly here like usual, and then you can move the assembly from the custom library, you can move it to the project library. And so now this assembly will only get saved into the current Hero file that you're working on, and just allows you to really keep your assembly library clean, create custom libraries just for specific projects, and then not use them or not, you won't need them again in the future. You can move them back from a project library. If someone gave you a file and it was in the project library and you wanted to use that assembly on other jobs, you can move it to the custom library using this new button up here. The other new aspect added into the wall library is the ability to change the type. So the type is like a grouping. Inside Hero, we have, brick veneer groups, fiber cement groups, weatherboard groups. Use this move button here, and you can move an assembly into a different group. You could even create your own group here and say, my new group. And you'll see here in this, sorry, I'll clear it up a bit. In this custom library, we now have the fiber cement group that has one, the weatherboard group that has one, and our custom group that we just moved it into. The last update to the construction library is a good one. If anyone's been doing NatHERS modeling for a while, you'll realize that the insulation materials that we've been provided by NatHERS CSIRO are not particularly representing real world conditions. So R2.5 wall bat, 110 mil. There's not, I don't think, a single producer who makes 110 mil R2.5 bat. So we've always had this inaccuracy of thickness in our NatHERS assessments, and it's been typically just tolerated. Well, with 3.1, we have a lovely way to model at size, finally, of insulation options. And so what we can do now is, you can see this little lightning bolt in both the thickness and the R value columns. We can always overwrite these previously, but if I change the thickness, typically in Hero, it will just change the R value based on that thickness change. So if I change it to 150 mil, it'll increase it. But what I can do, if I turn off this lightning bolt, which is meant to be like automatic linking, I can override this and set this wall to 90 mil and override that thickness. Oops. And then I can set, again, I can override this kind of automatic linking of thickness to R value, and I can just create my own 90 mil R2.5 bat. For non-NatHERS assessors, this might be irrelevant, but it is really nice to have actually matching thickness assemblies that actually match the real world conditions. So you can now see in this project what we've just created is a 90mm R2.5 variant. For the nerds, what does that actually do in terms of Chenath? So in the end, what we do is that 90mm will be used geometrically across Hero, but in Chenath, we model it as the traditional 110mm thick in the Chenath simulation. But for all of your shading calculations of eave projections and screen distances and all of these kind of things, it relies on this geometric thickness. So again, we're kind of handling it for you. You don't need to worry about the impacts on your simulation. It's not going to really impact anything except that your eave projections and all of these kind of things are going to be accurate. So that's a nice new add into 3.1. Look forward to hearing your feedback on the update. I hope you get stuck into using some of these new features, letting us know what you think about them, getting stuck into NatHERS 2022 projects, and exploring some of these new features that we've added in. So I'll step into reading through this long list of Q&A and see if I can answer any of them. Okay, Nayan Das, will there be 2 certificates, one for thermal fabric and a second one for a combined thermal fabric and hollow house? Yeah, so the, I'll have to share my screen again, sorry. Hopefully I covered that one, Nayan. This is the 2019 certificate on the left. This is the 2022 thermal fabric certificate on the right. And if you do in future, when Hero's got hollow house introduced and you use a hollow house rating, when you upload that project to the Hero web portal, this hollow house rating aspect, 50 out of 100 or 60 out of 100 will get populated as well. Anonymous is asking, can you still run your model without adding the structure? Yep. So there's this setting none. That just ignores that. Obviously for 2019 projects and non-steel frame homes, you just leave it at none. You don't need to model structure. You only need to model structure for 2022 steel frames. You can obviously model timber and go beyond. Joe Davey asks, what happens if it is cavity brick? We just ignore the structure tab. Look, there's a range of kind of NatHERS guidance on this, and there are some edge conditions that I'm not sure have been fully clarified by NatHERS, CSIRO, or the AAOs. Things of, portal frame steel homes and where things diverge from typical assemblies. Cavity brick, in my opinion, is, you're going to ignore the structure. You're not really going to have a timber or a steel frame down the cavity of a double brick wall or a cavity brick wall. So yeah, you would ignore it there, Joe. Manuel asks, are the thermal bridging calculations based on NZ4214? Yes, thanks, Manuel. Good pickup. I was meant to mention that. Yes, so in the NatHERS methodology paper on thermal bridging that you can go and check out, it is, not loosely based. It is mostly based on NZ4214 as a standard. There are some slight variations away from that standard just because of the way, say, air gaps are modeled in Chenath and a few things like that. But it's mostly trying to align with NZ4214, yes. Anonymous asks, with the thermal bridging in the walls, is it input into the new Chenath as a derated R value? Again, yes, something I probably should have covered. So in the end, all that thermal bridging does in a Chenath simulation, it doesn't model that second material in Chenath. It just derates the primary layer. So if our insulation was 90mm and we had a steel frame that reduced that R2 to R1, just for a simple example, so halve the R value, instead of modeling that in Chenath as 90mm, it'll just get modeled as a 45mm insulation layer. So the secondary material doesn't actually get modeled in Chenath. It's just a derating applied in the scratch file to the primary insulation layer. Craig Cantwell asks, is there a default for floor? Yes. Yeah, one of the, each of the categories in the NatHERS tech notes, there is a default steel frame type that you're meant to use. If you don't know what the floor steel framing is or the ceiling steel framing is, you use that default. Alex is asking, is the full thermal bridge modeling valid for the purposes of NatHERS 2022? Yeah, there's nothing to stop you going beyond NatHERS 2022 and modeling more thermal bridging, like timber thermal bridging. There's nothing to prevent you really, in our opinion, from doing that and going beyond the limitations of this kind of NatHERS methodology, I suppose. Yeah, but you obviously don't need to. And in most cases, you'll result in a drop in performance by modeling full. Yeah. Joe asks, I noticed a checkbox for the air gap in the thermal bridging structure tab. I think I know what you mean. Let me bring it up again. I think you maybe mean air films. This is just a new checkbox in Hero that you've maybe picked up. It's actually just the external and internal air films, and whether your total R values are accounting for air films, depending on whether you might be using these this assembly table for, say, DTS or whatever. Sometimes you'll want to include the effect of air films. Elaine's asking, is it possible to just set different comfort thresholds for different zones? No, good suggestion. We're looking at a few. Yeah, this is our first pass. We'll definitely be continuing in the enhancements there. Carl Robinson asked a good question. 3.1, unfortunately, is not yet ready for Mac. It's a Windows only release, just because we are doing so much on the whole house side. All of our, the main Mac aspect is remote simulations. And so there's been a lot of changes in the remote simulation stuff there. So hoping to restore Mac functionality really soon. Apologies to Mac users there. You'll have to run virtual machines for the next few months. Mike Kelly asks, when modeling in full thermal bridging mode, are the calculations for both steel and timber done within Hero or within Cheneth? That's our calculation that we apply into Cheneth, Mike. So I suppose every software tool is going to hopefully follow the same calculation methodology, but we've all derived it ourselves. Mike also asked, regarding roof level insulation, like a blanket, this would not be bridged by timber or steel. Yeah, so that's another one that I think the NatHERS administrators could probably clarify. I mean, when you do have a roofing blanket installed at the roof level, disrupted by steel battens, that is bridged, in my opinion. Whether you model it as a structure in your NatHERS assessments is probably, I'll leave it to assessors to decide, or confirm with their AAO. Avona says, the ability to change insulation thickness is nice, but since it's in the wall, can't the initial thickness be fixed to 90 mil and then changed for other walls? Yeah, I think, in the end, our defaults should be closer to the truth rather than requiring you to override them. I suppose there were elements of kind of compatibility of previous files suddenly coming in, and we've changed all of your 110 mil walls to 90 mil insulation. We were just a bit worried about the impacts there. But yeah, we are looking at a way to make it a bit easier to, save and use these 90 mil, updates. What you've got here now is in your, Hero library, this 90 mil, if I close Hero now and boot Hero back up, that's now saved into my default library. I can use that on the next job and the next job and the next job. So, and I can select that in my template for the next job and stuff. So it is relatively easy to add into your typical working practice. Clyde asks, can we claim technical CPD without AAO for this presentation? Yes, sorry, Clyde, I should have confirmed to you last webinar. Yeah, most of the AAOs have accepted these Hero webinars as CPD, so contact them to try to get that recognized. Anonymous asks, for projects in New South Wales, basics will still cover what's included in Whole House. Yes, that's correct. So basics unfortunately haven't integrated NatHERS Whole House. They're still kind of outside of the NatHERS Whole House methodology. So all of this Whole House work we're doing in Hero unfortunately won't be used in Hero, in basics, sorry. Hint, hint, we should all put a bit of pressure on. It'd be good if everybody was using it. Michelle Wright asks, do posi-strut floor framing needs to be modeled for thermal bridging? Oh, good question. Yeah, I think this is one of those edge conditions. Is it timber? Where does it become steel framing? Yeah, I think if there's any timber involved, that's probably going to break it. such that you don't need to model such an assembly. But yeah, I do think there's still some edge cases that we need greater clarification on for sure. Rebecca Boyle, is there a plan to add the peak heating and cooling loads in the viewer results? Yes, I think so. It should already be in there. And that's a good example, Rebecca. So when you run a thermal fabric assessment in Hero, you'll get your GenS simulation will determine a peak heating and peak cooling load for that project. And you can use that new hourly results viewer to kind of see that day in the energy chart. You know, when you're in this hourly results viewer, turn on the energy chart, go to peak heating, and that's the peak heating. These two shortcuts are only going to be used for kind of condition profiles for peak heating. Excuse me. Here's our peak 37.5 kilowatts of thermal load delivered at around 8 a.m., which is when the NatHERS profile kicks in. So yeah, you can use these peak heating, peak cooling events to try to work out a bit more about your HVAC performance, noting the limitations, I suppose, of NatHERS profiles on HVAC sizing. Can the new features in the project tab be saved in a template? Do they have to be selected for each project? At the moment, the template does have a few of these new variables of honor that we do need to add. Structure isn't in the template yet. So yeah, that'll be in the upcoming release. Mel says, I provided my first thermal comfort results to a client this week who was very excited to have so many results to help with optimizing. That's great to hear, Mel. Good to hear that you're using that new feature. And I do think, you know, my experience of ESD and energy ratings, you know, is the more information you provide to your client, more charts, more images, more analysis, more data, the better the outcome always, and possibly the higher the fee. So yeah, give them more. They're an option for vertical members to be calculated. I think, Adam, you're asking, can you add in customized structural materials? At the moment, when we drag in this structure material here, there are just at the moment a range of different defaults that we've added. We will be adding the ability to click, you know, add your own custom one where you'll be able to define your own spacing, thickness, steel thickness, noggings, custom R value of thermal breaks, etc. So that's coming down the line. Obviously, we've just got compliance dates that we're needing to meet at the moment. Cindy asks, what happens if we have a good quality wrap? How do we model that so the thermal bridging impact is reduced? That's a good question. We were just debating that actually with Sarah yesterday, of whether continuous insulation on the outside of a steel frame is a thermal break, where you could claim a R.2 thermal break on that wall, as well as model the insulation here as an additional, sorry, what am I doing now? You can model, if I had two insulation layers, it's got a bit stuck. If I had two insulation materials in my assembly, and one was just a little, you know, 15 mil continuous layer of insulation, like a sarking product with a bit of bulk insulation, is this thermal break, such that I can claim it here as a thermal break, plus also claim it as a continuous layer on the outside? I think the clarification, Cindy, is that you can kind of not double claim it, but call it a thermal break here and have, but this is the thermal break layer that you're also modeling continuously. Kevin asks, in terms of optimization, it applies one, the optimization currently is, as Kevin asked in his question, you know, it's going to apply R1 to all your walls, R1.5 to all your walls, even if they don't have insulation. So there are enhancements to the optimization coming down the line where you'll be able to filter, and there'll be a new filter thing under here where you'll be able to say, you know, walls that are in condition zones, or walls that have existing insulation, or walls that are brick veneer, and vary there, Kevin. So yeah, I get what you mean there. Walter asks, will the optimization results show the two results when you have more than one dwelling? It will be running that multi-dwelling. Yes, Walter? Yeah. Is incorporation of embodied impacts on the horizon for Hero, Alistair asks. Yes, post Holler House, we're keen to get that in for sure. And that's where some of this thermal options is kind of being designed from. You know, now that we have the structure, which might be timber, might be metal, we have a lot of the information ready for an embodied emissions calculation. So we're keen to get into that. Are you planning to bring in the results of full factorial analysis as a pass-fail to the UI? That's an interesting idea, Manuel. If you have any further questions, let me know via email or hit us up on our support page. Otherwise, we hope to talk to you guys soon for the Holler House release. So we'll be hopefully in touch in the next month or so. But looking forward to hearing how you go on version 3.1. We hope you appreciate it. A lot of new features that we're excited about integrating and carrying on future development of. So thanks to everybody for your attendance today, and yeah, look forward to talking again soon. Thanks.